Hi, everyone, and welcome to this new session of the Generative AI Level Up Tuesdays, where we are going to deep dive into the world of agentic AI and especially Azure AI Agent Service. So I'm Carlotta Castelluccia. I'm an AI advocate at Microsoft, and I'm here today with Amanda Foster from the Azure AI Agent Service product group. How are you doing, Amanda?
Great. Excited to be here today and talk about AI agents.
Awesome. Thanks for being here. All right, let's set the scene for the next 60 minutes or so that we are going to spend exploring the AI agent world. Last week, my teammates Corey and Chris did a great job introducing you to the agentic AI world, explaining what is an agent and presenting the current agentic AI frameworks landscape in the Microsoft ecosystem. Today, we are going to dive deeper and go through an end-to-end sample built with Azure AI Agent Service, which addresses a specific use case. But before jumping into our sample, let me just do a step back and start with the why. So why we need agentic AI and what's the benefit they brought with respect to just, consuming large language models. So let's look a bit at the AI progression in the last year or so. We started with interacting directly with large language models, and we know that large language models can take natural language as input, speak many languages, can process multimodal inputs and outputs. They can help carry out tasks and also act as tutors. But in terms of user experience, they provide a simple back and forth chat with the user. They can also be grounded on private data, so their knowledge can be extended, so they can provide more accurate responses using patterns like retrieval augmented generation. And they can also be customized through techniques like fine-tuning. But the next step is what we called triggered agents. This is one step further because they are goal-based and they can take actions independently. So they are still based on large language models, as the model is the agent engine, we can say, but they also have access to data and actions. They are semi-autonomous because they may require minimal user intervention, or they could also ask other agents for input. And given a goal, they will work to achieve that goal without you knowing in advance exactly how it's going to do that or what steps it's going to take. They also have memory, as agentic frameworks usually handles the conversation context and truncation for you. And then, as I mentioned before, an agent can also work with other agents. And so the next step in this AI progression we see in this slide is multi-agent systems. And multi-agent system can be built to address more complex scenarios where we want to provide fault tolerance. So for example, we have an agent reviewing the work of another agent, or specialization. So we want different agents specialized in different things, and also scalability for larger workloads. So to summarize the in 3 points, what an agent should be able to do is, first of all, reason over a provided business process, integrate with data sources for additional context, and orchestrates a process towards achieving a goal by performing actions on behalf of the user. So this is an overview of why we need agentic AI, what's an agent. But Amanda, I know you would like to start with an example to kind of demystify a bit what's the impact of the agents in the market.
Yeah, thanks, Carlotta. Like she just kind of introduced, when I first heard this overview, what kind of came to my mind is like, what does this all really mean? And I think to better illustrate what is an agent, I wanted to focus on a concrete example that I think really shows their impact. Take, for example, this process diagram on the screen. And in the first click, as you can see, with agents, you can start automating manually and repetitive steps in this process diagram. One thing I wanted to just call out is HR managers are not going to, like the whole HR manager row is not going to be replaced. And that kind of means, in summary, agents are not replacing jobs anytime soon because tech isn't that advanced, but you will see an agent, for example, that can send a personalized email, answer questions, structure some data. So the overall impact is the AI will help take care of that kind of busy work and repetitive tasks, so you can focus on high value tasks, or like we joke on our team, you can even become a manager of your own fleet of agents. And yeah, I think that's really the value and impact I see agents driving for productivity. And now I'm going to pass it off to Carlota to walk us through and introduce our use case, where we can hopefully kind of hone in on this further.
Exactly. Thanks for this example, Amanda, and for really put all those stuff into practice. We have a specific use case we want to address with an agentic AI solution today. So let's present these. So throughout this talk, we are going to pretend we are a successful outdoor and hiking equipment company, which we're going to call Contoso. And we want to use the power of AI, of generative AI, to analyze our sales data. So this hiking company has an e-commerce selling camping equipment. And we want to analyze our sales data, of course, to keep improving. And we want to do that by leveraging generative AI and agents. So let's move to a quick demo in a way that you immediately understand what we are talking about. So the app I'm going to show you is a conversational agent that can answer questions about sales data, also generate charts, as you will see, and do further analysis. This app is built with Azure AI Agent Service and is based on the Azure OpenAI GPT-4o model, while the UI is built with Chainlit. This app also uses a read-only SQLite Contoso sales database with 40K rows of synthetic data. So when the app starts, it reads the sales data, the product categories, the product types, adds this info to the Azure Agent Service instruction context. So the app I'm running in here is deployed with an Azure Container Apps. So first of all, to interact with this agent, I have some prompt starters. I'm going to start with the help starter to understand how this agent can help me. So as you can see, the first interaction is just, the agent is telling me that it's here to help with sales data inquiries at Contoso. So let's go with Let's go with the next question, which will be more focused to our scenario. So I'm going to ask to create a vivid pie chart of sales by region. And as you can see, the first thing that the agent does is it prints out the tools that it needs to answer these questions. And the tools are a function called ask database that takes as an argument a SQL query, which is executed against our sales database. And then we have the code interpreter tool. We have the code interpreter tool. So basically the agent created this Python code to generate the visualization starting from the result of the SQL query, and then also executed this code into a Python sandbox environment. And that's the result. This is the graph we have asked for. So as you can see, the agent is using tools to generate responses, which is not just which is not just textual responses, but it includes it's a multimodal output, so it includes images, and it is achieved by using tools without me explicitly tell the agent what kind of tools it should use. But let's try with another question. For example, let's ask what beginner-friendly tense does Contoso sell? Now, as you can see, the agent is not able to really answer correctly to this question because what it is relying on right now is just a sales database that doesn't contain information about beginner-friendly tense. So what we can do is we can upload a file, a PDF file in this case, that basically is a products catalog of my Contoso selling e-commerce, and then trying asking the exact same question. So what beginners-friendly tense does Contoso sell? And see how the agent keyword changed. So first of all, it is uploading the files to be able to access this context. And then, as you can see, the answer is changing because what is happening in here is that the agent is using a tool which is called file search that basically creates a vector store upon the file that I have uploaded. So it is able to use the file as a context to ground its responses. And as you can see, I also get some citations in order to, in a way that I know from which file the responses has been extracted. In this case, we have uploaded just one file, but there are cases in which I have several files, so I want to know where to find the information. Let me show another bit. So, for example, I want now to test the agent to be able to combine the information extracted from the sales database and the information extracted from the file. So I'm asking it to create a table that shows sales of backpacking tents by region, but also the description of the tents. So the sales by region can be extracted by the SQLite database, while the description of the tent should be extracted from the files. And as you can see, the agent is working on creating this table. And it used, again, this function to extract the information from the SQLite database. Here we are. It's still producing the table. Perfect. And I also have, again, the citations from the file where the information have been extracted. And the last request I can ask to the agent is to create an Excel file from this table. So I don't just want, the table printed in here, but I also want to be able to download a sales report as an Excel file. And this time, the agent is using the code interpreter tool again to generate the code to create a file and make it accessible to the users. So as you can see, it's writing the code in here real time. And then it's executing this code in a sandbox environment. And if I can scroll up, okay, I get my Excel file with my sales report. Here we are. So as you can see, in a few seconds, I was able to, by interacting with the agents, to get information about the sales of the Contoso e-commerce, information about the products by uploading the files, and then also downloading an Excel file with the results of this insight. Well, but let's come back to the deck because we have showcased right now just what we can achieve by using agentic AI. But this might look like a black box. So don't worry, we're going to, break down every pieces throughout the session. So back to you, Amanda.
Yeah. Thanks, Carlota, for that great demo that really showed us, again, exactly the power of this service. Now we're going to spend kind of the next section and next part of this presentation diving deeper into how exactly Carlota and I and the rest of the team actually built this sales application. And we just to address, there are a lot of frameworks out there to help build agents, as you've probably heard. There's semantic kernel and autogen and langgraph and langchain and crew AI. But one kind of issue that is usually common among these frameworks is they leave developers with a lot of complexity. For example, developers have to handle state, context, tool orchestration, scaling, and so much more, which can be very challenging. And this brings us to why we actually chose, and as Carlota will show on the next slide, this will bring us to, again, exactly why we chose our agent service to help out with this problem. We're going to use the new Azure AI Agent Service because it specifically addresses the complexity by allowing you to build, deploy, and scale AI agents with ease. And the way it does this is a few things. The first is it simplifies development. As a fully managed service, it comes with state management because this is a stateful set of APIs, context management. It will decide what tool to call and actually call it on the service side for you. We have integration with an extensive ecosystem of knowledge and action tools that, as Carlota will show later, you can implement in like 3 lines of code because most of these tools are implemented as built-in tools with developer needs at the forefront. We have support for a wide variety of models and are not, again, including non-OpenAI models, because we want you to be able to build agents with the latest and greatest kind of model and whenever that comes to market. And then lastly, we kind of package up all of these features with a built-in enterprise readiness. And I'll kind of get more into that enterprise readiness on the next slide. So before we dive deeper into the demos and kind of core components of this agent application, I really wanted to start by just calling out one thing that we won't be showing in the demos, but is just super important because none of this would be possible without our enterprise foundation. Security is a top priority when building agent apps in an enterprise environment because agents are handling customers' most sensitive data, they're interacting with external systems, and therefore they must be protected from misuse. Our service is built to meet these rigorous enterprise requirements with built-in features like support for tracing and monitoring to ensure your agent's not hallucinating, content filters to protect against prompt injection attacks, the ability to use your own resources by default. So all customer data is stored in your own resources, which are in your own tenant, and you have full visibility and control over. Support for private virtual networking with one of our setup experiences to secure data traffic, keyless setup, authentication, and honestly, so much more. So now kind of transitioning into what our solution architecture for this application looks like. And kind of the reason I'm even putting this slide on the screen is to really, again, kind of hone in on the fact that most of this application is managed by our Azure AI Agent Service. As you see, the instructions, the models, all of the tool calling is handled and managed for you within the service because ultimately our goal is to make it so a task that previously would have taken weeks or months now takes you days or weeks, and we just want to get your agents into production as fast as possible. So now to kind of transition, this slide's going to be a little bit more of a drill down of agent service in action. As you can see on the screen right now, this is kind of at a high level how the agent service works. The first step is you create or define an agent. The second is you create a thread, which is essentially a unit of conversation between the agent and the user. The third step is that thread will then trigger something called a run. You will continually on the application side check the status of that run. And once it is complete, you will then show the output to the user. But now I'm going to kind of break this down even further. So the first step that I touched on was to create an agent. An agent or how we define an agent, because there's a lot of kind of a definition of an agent is not aligned across industry, but how we define an agent at Azure AI Agent Service is an agent is composed of a set of instructions. These are natural language instructions, essentially a prompt for the agent overall, a model that you can choose from. As you can see, we support Llama, Cohere, and have just even more non-OpenAI models support on the way, as well as all OpenAI models. You have the option, as I addressed on the enterprise readiness slide, to use your own resources for every component of this service that stores customer data. So you have fine-grained control over all of your sensitive information in this service, and nothing will be stored on our end that is your customer data at rest. And then lastly, you have the option to easily configure a bunch of our out-of-the-box or custom knowledge and action tools. Some of them include file search, Azure AI Search, code interpreter, support for custom functions, or even service-side functions like Azure Functions, and just so much more. And we'll get into really the power when we show you how to implement these tools later on. But the second part of this process is then a thread is created. And a thread, again, like I said, was a conversation session that stores messages. And when the user sends their first message, what is called a run is triggered. A run essentially is the activation of an agent based on the thread's previous content. And the agent will then use its configuration in the thread's messages to perform tasks. I mean, as you can see in the example, some tasks could include like calling a model, invoking any tools that are needed, and then finally, as a result, it will append the message to the thread. One thing I wanted to call out lastly is that, as you can see in this last step, a single thread can have multiple runs. So once the user sends in their next kind of follow-up question, a second run will be triggered, and kind of the same process will follow. And this run will have access to the previous entire thread conversation history. So the agent is learning as it's going and is a stateful API that will maintain the current conversation history. So now we are going to kind of transition over, and I'm briefly going to introduce the next kind of big core section of our presentation today, which will be a look into some of the building blocks of what really is this service, or what I've referred to kind of on the previous slides as our agent tools. To start off, I wanted to kind of introduce, and this will be our first demo, function calling. As many of you are probably familiar, function calling allows agents to interact with other systems. OpenAI and other large language models today support function calling, and how these models work is essentially you'll provide the definition of a function call. The LLM will then use that definition and all the training data it has to, when you're asking it questions, detect conversations that they believe would satisfy a function call. And then what they will return to you is the structured kind of data or output. But really on, again, the client side, the application side, you are responsible for then taking that output, that structured data, and actually calling the function yourself. In the next demo, you'll see we will use function calling to execute a SQL query and return the data as kind of context to the model. But I want you to especially pay attention to the built-in kind of function support we have with our Azure AI Foundry SDK that is aiming to simplify this experience. The SDK specifically will parse and execute these functions for you within streaming. While this is still on the client side, it drastically simplifies this experience. And we also do provide service-side support for some custom actions and functions through Azure Functions and Logic apps, which will be coming soon. So now I'll pass it back to Carlota, who's going to kind of really jump into the core demos and get into the code base, show us how to actually configure these tools.
Thanks, Amanda. And before jumping in, I just want to address a couple of questions that I see in the chat. So hopefully I will answer a few questions while doing the demos in terms of how we define the tool, how we the tool that the agent can use, or how we can do real-time interactive visualization, real-time visualization using code interpreter. But what is important, what I would like to highlight, I've seen a couple of questions about, so what's the difference between a large language and using just a large language model and using an agent? What's the difference in terms of use cases? What's the real benefit of using the agent? So I want to stress out that the main difference is that what you have seen in the first demo is, for example, when the agent has created the graph, the agent was responsible to create the SQL query to run against the SQLite database, and then also to create the code, the Python code to generate the graph, execute the code in a sandbox environment, and then generate the output of the graph. If I was using a large language model, I would have all these kind of automatization wouldn't have been possible just interacting with the large language model. I could have asked for I don't know, some help in using a tool to create a graph, or maybe I could have asked for the code to create the graph, but then I should have executed it on my own. And the other important thing is that the agent is the agent is deciding in here which tools to use in which occasion. So it's not me telling the agent, okay, now use this tool or this other tool. So it's the real difference is about the automatization of all these tasks. And you will see also in terms of code, since there are a few, all these tools are easily integrated with the agent. There are built-in functionalities that enable us to add these actions to the agent. It's also very much easier to in terms of coding experience. I don't know, Amanda, if you want to add anything on this point before we jump into the demos.
I think you did a great job giving an overview. I think we should really jump into the code base and show you this in action, because I think that's how you really can see the power of what we've referred to as these built-in tools.
Perfect, exactly. Great. So let's jump into Visual Studio Code, and this is the code of this end-to-end agent sample we want to show to you today. And I'm going to, don't worry, I'm going to share with you the repo as well, so you will have access to the code. So what I'm showing is basically the backend of the agent we have interacted in the first demo. And the first thing I want to show you is how to enable function calling. So how to being able to call the function that create the SQL queries and run it against the SQLite database of sales data. So in this main.py file, we have the main logic of the app. Of course, we are importing here the required libraries. We are retrieving the environment variables that we need to instantiate our project client, which is the basically all the AI services in Azure AI Foundry are available, accessible through this project object, which is basically your workspace in Azure AI Foundry. So we instantiate with this project client that make all the Azure AI service related to the Azure AI Foundry platform available to you. And then here's where we are declaring our function that we are going to use for our agent. So if we go into the definition of this function, we can see in here that we have these async fetch sales data using SQLite query, which is a function that executes our SQLite query against the database and then returns the results as a JSON object. So it basically have as input the SQLite query, which is generated by the large language model. And then it returns a JSON object which contains the result of the execution of the query against the sales database. And what I want to highlight in here is that the Azure Agent Service makes it easier to call function by using these docstring to specify signature, outputs, inputs. So the large language model, which is the agent engine, process this information to be able to make decisions on when and how to call this function. So coming back to our main logic, the other thing we are going to do is declaring an instruction files. Let me open it so we have an idea of what's going on here. So in these instruction files, basically I have the system prompt to my model. So I have a definition of the persona of our assistant, which in this case is an assistant that helps with the sales analysis. We have a definition of the tools that the agent can use. In this case, our function, for now, we are just enabling it with the function, so the fetch sales data using SQLite query function. We have some guidance in terms of the questions that should be able to address, and in terms of guidelines, so some safety guardrails. And then what we do is we add the agents tools that, again, for now, we are just adding the function we have declared before. We have just one function for this example. You might have multiple functions, of course. And then we initialize the agent by adding the agent tools, again, just the functions in this case. We connect to the sales database, the SQLite database containing the sales data. We open the file instructions and we make it accessible to the agent, and then we create the agent itself by specifying all the parameters needed. So the model, which in this case is GPT-4o, the name, the instructions, the tools we have declared, and so on and so forth. Then, as Amanda explained in the slides, we create a thread, which is these basically kind of conversation session with the user, and on the user input, so on when the user input a messages, we create a message object and a stream. And then we post the response of the agent as a reply when done. So let's run this code and see and test it in the console. So as you can see at the starting of the application, we are creating the agent, we are creating the thread, so we can test it with a similar prompt as before. So what are my sales by region? And as you can see, the agent is calling the async fetch sales data function that we have declared. It is executing this query that it has generated to get the sales by region, and then it is generating this table as a reply. So something similar to what we have seen in the UI, we are seeing in here in the console. But let's go to another. Let's use another prompt we have used before. So create a vivid pie chart to show the sales data by region. And as you can see in here, I'm not getting the visualization, and that's why, and that's because I just declared a function that is able to generate a SQL query and execute the query against the SQLite database. I haven't added any other kind of powers to my agent to be able to create some custom code, generate some custom code to create the graph. So the only thing that the agent can tell is, kind of guiding me on how to create the chart on my own. So what we can do here, let me stop. What we need here is an additional tool, which is the code interpreter tool I have mentioned to you before, and Amanda has mentioned it as well. So this code interpreter tool is the tool which is able to, which enables the agent to generate some custom Python code and then execute this Python code into a sandbox environment. So again, it's a built-in tool. So as I said, it's very easy with these kind of service because you just create the object, you add the object to the tool set, and that's it. The other thing we want to do is using a different instructions file, because this time we want to explicitly tell our agent that it could use the code interpreter to generate visualization. So this is a similar file as before, but in addition to my function, I'm telling the agent that to create visualization, it can rely on the code interpreter tool. So with the, just these two quick steps, all the rest is the same as before. I can run again my app and ask the same prompt as before and see if there's any difference. No, not this one. Let me copy this again. So create a valid pie chart to show my sales data by region. So it is executing the query because, of course, it needs to, retrieve the sales data from the sales database anyway, and then it is using the code interpreter tool to generate the code for creating the graph and executing it into a sandbox environment, and we can see the result in here. Let me see, where is it again?
Carlota, maybe reload your Explorer, like you go to the top.
Yes.
Yeah. Like refresh it.
Mm-hmm. Yeah, done that. It should be
in files.
Here we are. Okay, here we are.
Yeah.
Here we are. Here's our pie chart that has been, created by, and to answer the question I've got before, this was created interactively. So the agent generated the graph once I asked for it. Perfect. So let's do one more step. And let's ask for another prompt that we have used. Let's see. For example, something we have done before is creating an Excel file with the sales data. So let's ask for the same. Let's ask to download the sales data by region. And again, similar to what we have seen before, the code interpreter tool has been executed again. So to generate the code to create the Excel file and then to download it. And so we can see the result in here that has been created. So this is the sales data. Can you still hear me? Okay. I'm audible. I think I have a small delay. Okay, perfect. So using again the code interpreter tool, we've got this sales report as similar to what we've got in the UI. Let's try another prompt. So let's try something different, like what brands of pens do we sell? As you can see, these fails, so the agent is not able to assist with that. And this is similar to what I've tried before in the UI, before uploading the file. By just relying on the sales database, the agent is not able to answer those kind of questions. It can answer just sales questions. So let's enable another tool, which we have mentioned before, which is the file search tool. So I'm going to use another instruction file. Let me show you this one, which is basically very similar to what we have seen before. But in addition to, in terms of tools, in addition to the function and in addition to the code interpreter, which the agent can use to create visuals and charts, we also have these Contoso product information vector store that includes a local file that we are going to upload. I'm going to show you in a moment, that the agent can use to ground its responses. So let's enable this file search tool by uncommenting a few lines of codes. So what we are doing in here is we are creating a vector store on top of this tense datasheet file, which is the same PDF file I have uploaded before using the UI. I'm now uploading it in the via code, and then I'm going to create this file search tool object and add this object to the toolset. So again, this is a built-in tool. Just a couple of lines of code. I can create a vector store on top of my file and then add the file search tool to my tool set.
Carlota, if I can add just one point of clarification. I know I had touched on earlier, there's this optional step when you create an agent to actually bring your own resources. And I think this file search tool is actually the best way, an example of how I can talk about what is the impact of this. So we actually built our service on top of a service called the OpenAI Assistance API, but we are a completely separate service on a completely separate GA timeline, and we are not dependent on OpenAI. Again, we don't have to use only OpenAI models for our service, but one of the key this was a tool that existed previously in the Assistant API, but we've extended this, black box functionality where previously managed multi-tenant resources, they were actually in the Microsoft tenant, were used when you uploaded a file and then it used a multi-tenant Azure AI search to create your vector store. And now if you bring your own resources, that will be changed so that every single time you upload a file, it will go into your Azure Blob storage. And every single time that those files are then ingested to create a vector store, those will go into your customer tenant Azure AI search resource. So that's just, I think, one thing I wanted to kind of use this as an example to illustrate.
Yes, and thanks for clarifying this point, Amanda. And since I've stopped for a bit, I want to address also a couple of questions coming from the chat. I see IJ asking, what is the function? Is that function in programming or Azure functions we are talking about? So in this specific case, when we talk about function calling, these are programming function, custom functions you declare. You have seen before, I have in here these, let me open it again. I have this custom function in here, which basically just take a SQL query and run it against the sales database. But Azure Agent Service enables also the integration with Azure Function. So both are options that you could use in order to add more capabilities to your agent. And then I've seen another question about the instructions. Were the instructions generated with AI as well by Max? No, the instructions that you have seen, so these prompt in here, they are manually created. Of course, if you want, you could use AI to help you also generate prompts. But you want to also, review the final prompt you submit to your model, just make sure that it includes everything it needs, that it includes, for example, also safety guardrails, all the tools the agent can use, and so on and so forth. And then I've seen another question about, is the agent we created in our service or in Azure or in the general cloud? Is it always live? So this agent is created using the Azure AI Agent Service. So yes, it is. It is created as within our Azure AI Foundry project. So it is running on Azure, and it is an Azure resources. I'm running it locally, but it is an Azure resources. How does it learn from prior prompts using our data? So with the agent, the Azure Agent Service, but generally speaking, also with our other agents framework, what it happens is there's a concept of memory. So the conversation history is basically handled by the service in this case, and truncated in a way to fit the model's context to keep, always the most recent conversation history.
And I can add one thing about like the setup of an agent and what exactly when we say an Azure AI project, like what that means in terms of the specific Azure resources that will be hosted in the cloud. We have technically three, but two very distinct setup experiences. One of them is basic setup. It again still uses those managed multi-tenant resources that were used previously with assistance, and the resources kind of that are in your own customer tenant that are involved in the setup are an Azure ML Hub, an Azure ML workspace project, and then an AI services or Azure OpenAI resource. And those are, again, the specific resources that will be in your customer tenant. That setup is great because with the multi-tenant resources, especially with something like Azure AI Search, the cost is very minimal compared to our standard setup, making this setup great if you want to just kind of get started, assess value of the product, but don't really want all the overhead that comes with using your own resources. Which kind of brings me to the second main setup experience. We have this setup, which we call standard setup, with public and private networking support. And this setup is based on the same Azure ML Hub will be in your customer tenant, Azure ML project, and then all of the resources used to store customer data, as well as a key vault. And those resources are an Azure AI Search resource, an Azure Storage account, and coming soon, a Cosmos DB. And those will all be in your customer tenant. But like I said, there is a cost that comes with this fine-grained control of resources.
Perfect. Thanks, Amanda, for adding this. So just to recapping here, I've added the file search instruction file here. I've enabled this file search tool, and I'm running this again to show you that you can see in here at the application start, we are uploading the file right now, the PDF file with the products, the Contoso products information, especially the TENS products information. And then, so basically the agent is able to access the context of the file right now. So if I ask the exact same question as before, which was what brands what brands of TENS do we sell? This time the agent should be able to answer me correctly because it's able to retrieve the information from the file I've just uploaded. But I want to challenge my agent again with another question, which is this one. So what beginner tents do our competitors sell and include prices? Now, we don't have competitors' data, neither in the SQLite database with the sales data or in the PDF I've uploaded. And that's why the agent is not really able to assist me. And as I asked, whenever the agent is not able to assist me because it doesn't have access to the information request, it's just says that it's not able to assist and we should contact IT for further assistance. So let me exit in here and let me enable the last tool that we might want to rely on to make the agent access data which are not available to us but might be available on the web, which is the Bing grounding tool. And in this case, we have created what is called the Bing grounding resource in our Azure AI Foundry project, and we have connected it to our project. And then again, with 3 lines of code, we basically just connect to our Bing grounding resources, and we enable the agent. We get the agent access to these resources to be able to search on the web and ground its responses on the results of the Bing search. And the other thing we do is we change again our instruction file to use these instructions Bing grounding file that we have in here, which again is very similar to what you have seen so far. But in addition to everything you have seen, there's a section on where to find the competitive insights for products and categories that can be so the agent can leverage on the grounding with Bing search tool to find this kind of information. So now if we run these again and we try to the same prompt as before, of course, it is still using file search, so it is still uploading the file at the beginning of the application. But if we ask the same question as before, no, I have not in here. I have it here about the competitors' products. Here we are. In this case, now the agent was able to answer me with some competitors' products that has been retrieved through a Bing search, so through a web search using the grounding with Bing search connection, which is built in Azure Agent Service. So we know we have just few minutes left. So I want to quickly go back to the deck and recap what we have seen. So we have basically enabled our agent, first of all, with function calling in a way that it was able to dynamically creating SQL queries and run them against a SQLite database. Then we added the code interpreter tool to make graphs. We added a context through file search and through Bing grounding. So Amanda, back to you for the final chapter.
Yeah, thanks, Carlota, for really illustrating how we could build this ourselves. And finally, I know we only have a few minutes left, but I wanted to briefly touch on what if we wanted to build our application and our sales agent that we just built previously using a multi-agent solution. So to just give a kind of brief definition overview of what even is a multi-agent system, consists of now multiple intelligent agents that will interact, collaborate, work together, and share in kind of do tasks like sharing information to achieve a common goal, either autonomously or semi-autonomously. And this pattern can be applied across a wide range of use cases, like tasks as simple as generating a report or as complex as automating like an entire kind of large-scale workflow. So now briefly kind of jumping into what is our, again, kind of product strategy overall across Azure, and kind of how we approach open source SDKs and Azure AI Foundry and what's the story there. When building a new multi-agent solution, you should always start with Azure AI Agent Service to quickly build, deploy, scale the most reliable, scalable, and secure agents. And then you can orchestrate these agents using one of Microsoft's two orchestration libraries, and those libraries are AutoGen and Semantic Kernel. AutoGen is built by Microsoft Research. It's a cutting edge, like state of the art research SDK, but one downside of this is you might hit breaking changes, but again, the pro is it's always up to date. You always are going to have kind of the latest and greatest. The next SDK I wanted to touch on is Semantic Kernel, and they kind of take all of that Microsoft Research, package it all up, and actually GA it to create like a production-ready kind of stable SDK experience. So again, the pro of that is you won't actually have any breaking changes, but it might take longer to have some of the newest updates get to that SDK. And coming soon, we do plan to have kind of a managed orchestration within our service, but really want to call out, even if when that comes, all of these are staying. There is like a use case and a place for all of these, and they all just kind of target different developer needs and different like kind of groups of people. So finally now getting to actually the last point, and really what I wanted to show you today, is how would we implement our app using multiple agents, specifically the Contoso sales application we implemented previously. But before I kind of jump into the diagram on the screen, I first want to say, like, why would we even want to use a multi-agent system? And the first is, as you may have noticed, like previously, like Carlota dropped like a boatload of prompts into one single agent. And this introduces a lot of complexity, especially as you add more and more tools. So one solution to this is, instead of having one like super agent that can do it all, have a bunch of specialized individual agents that each get like a specific part of that prompt and are responsible for a specific task. And this kind of diagram on the screen is actually my illustration to you of how we'd implement this app as a multi-agent application. We would first have a SQL agent. You would give it data, and it would have the functionality of being able to generate and execute SQL code via the function calling and code interpreter tools. The next, we'd have a data analyst agent that would take all the results from the SQL agent, reason over them with business knowledge, aka our file search tool with its product catalog and documentation, and Bing search, so it could have access to real-time live information, and then again reason over all of this. And then lastly, the user proxy agent, which would be the only agent in this system that has the power to actually do anything. And what I mean by that, for example, this agent is the only agent that can interact with external systems and send kind of queries or actually perform actions like executing code. So this is essentially acting as like a manager agent of this system and is like a connection point to the external system. But kind of a problem we had previously now comes in again, and that is, as the number of agents in your multi-agent system grows, the burden of kind of configuring and maintaining this system grows kind of proportionally, and there is kind of more complexity that comes with more agents. But one solution in the industry to kind of, again, get better results and more accuracy is something called a maker-checker pattern or a debating agent pattern. And how this would look in the context of our example, because for me it always kind of helps to use an example, is we could implement a quality engineer, and that would check what the SQL agent has proposed. So this new quality engineer agent and our SQL agent we previously implemented would be provided the same instructions and tools and context, and we would only be able to move to the next step in our process if both of them came to the same conclusion. And why this is useful is this significantly reduces the chances of errors, because the probability that both agents make the exact same mistake and like hallucinate in the exact same way is very low. So yeah, this is just briefly how we would implement our app using this multi-agent pattern. And lastly, I'd like to pass it back to Carlota to give us a brief summary of what we've learned today and just some key takeaways.
Yes, thanks, Amanda. And yeah, I just wanted to say that, the Agentic AI world is really fascinating. Probably we could stay in here, talking about agents for really longer. But since we are at time, I want to really just recap what we have seen today and give you some kind of next step that you could, and useful resources you could use to continue your learning journey with us. So what we have seen, we have seen the building blocks of a sample of an agent built with the Azure AI Agent Service, with tools like Bing, Azure function calling, code interpreter, file search. And then we have also talked about why we need agents, what are the use cases. And then Amanda also explained where the Azure AI Agent Service places itself within the context of other frameworks in the Microsoft ecosystem. So thank you so much for staying with us today. This is the link and the QR code to the repo that includes all the demos I have showed to you today. So if you want to, replicate them on your own, feel free to go to this repo and have a look. I think you will have the link in the chat as well. And then another link that I would love you to have to continue your learning journey with AI agents is these Agents for Beginners curriculum link. So go to aka.ms/ai-agents-beginners and you will find a full course designed by my team and Amanda's team on how to build Azure Agent Service, the different use cases, the different frameworks, and everything you need to know to really quick start with agentic AI. And I know we didn't have the time to address all the questions, but don't worry, we have some more time for you to answer questions on Thursday. Please jump into our Discord server. Again, you will find the link in the chat. We are going to meet again on Discord for 15-20 minutes, where we are not going to present anything more. We are just there to answer your questions. So make sure to bring your own question and take this opportunity to meet again and discuss further all your doubts and questions. Again, thank you so much, and thank you, Amanda, for being here on the stream.
Yeah, thank you for having me and for all your help. Carlita and her team have been just so helpful at putting together and working with us to create content so we can really just illustrate the impact that this service intends to have.
Thank you.
Thank you.
Bye, everyone. See you on Thursday.
Bye, everyone.